Good morning friends, welcome back to my channel Coding Environment. In the last video, I tried to explain what is queue data structure in Java. In this video, I am going to continue the same data structure which is queue, but in this video, I will cover what is circular queue or what is circular queue data structure in Java. So, if you are going for any programming interview, interviewer can ask you a question like write your own program for the circular queue. To write the own program for the circular queue, first you have to know what is circular queue and what are the basics operation performed in a circular queue and how we can achieve those operations. So in this video, I am going to explain what is circular queue and what are the basics operation performed on a circular queue. So without making any delay, let's see what is circular queue. Circular queue is a linear data structure in which the operations are performed on the first in first out principle. This is the same principle on which the normal queue also works, and the last position is connected to back to make a circle. In the previous queue data structure, the queue was in the linear format, like it was in a form of a straight line, but as this name suggests, it's a circular queue. So in this case, the rear end is connected to the front to make it a circle. It is also called as a ring buffer. In this circular queue also, the insertion and the deletion happens at the opposite end. So if I have to explain what is circular queue, these are the basic format of a circular queue. You can see that I have some elements which I have inserted in a form of circle. So in this, I can see that the size of this circle is 8. The index is starting from 0 and is going way from 1, 2, 3, 4, 5, 6 and 7. So the size of the circular queue is 8. Also, there is 2 indexes in this circular queue. One is the front and the next is the rear. Just like in the normal linear queue, we always insert the element at the rear position and delete the element from the front. In this queue data structure also, we do the same operation. We delete the element from the front index and insert any element into the circular queue at the rear index. So now let's see what are the different operations we are going to perform on a circular queue. So to perform any operation on a circular queue, just like linear queue, again we have to initialize this circular queue. So the basic element of this circular queue is the size of this queue, like what is the capacity of this queue or how many elements we can insert in this queue. So if you see, we have to define what is the size of the queue, just like we are initializing in the linear queue also. So here, if I have to initialize this queue, I am passing the size of the queue. This int size is nothing but the size of the queue. Also, we have to initialize what is the front and the rear value. This is the indexes which will maintain the insertion and the deletion point into this queue. So you can see here I have a front and a rear index which is initialized with -1. Also, the size is initialized with the size value which we are passing in this constructor. With this size, again we have to create an array. So you see there are 3 parts of this construction. One is we have to initialize the front and the rear index. We have to initialize or say what is the capacity of this circular queue, and the third one is we have to initialize this array also. So now once the initialization of this array is done, we can see what are the different operations we can perform on this queue. So before doing any operation on the circular queue, there is 2 important methods which we have to first understand. Before we go and do any operation on the circular queue, we have to write a method which can tell us is the queue is empty or is the queue is full or not. So we have to write a method which can tell us that the queue is empty or not. How we can say that this circular queue is empty or not? By checking this front equal to -1, we can say that this particular queue is empty or not. So if you see my previous slide, I am initializing this front index value equal to -1. So this is the value which front will contain when there is no element in this circular queue, or front will have a value of -1 when there is no element in this circular queue. So if I have to see that this particular circular queue is empty or not, I can check this particular condition. If my front is pointing to -1, it means my queue is empty. Again, we have to see a method which will tell this circular queue is full or not. So if my front is pointing to 0 and my rear is pointing to 7, I can say that all this value is already filled. It means this circular queue is already filled if my front is pointing to 0 and my rear is pointing to 7. So how we can convert this particular logic in the form of code? We can say that the front is equal to 0 and the rear, which is this position in this case, whose value is 7, is equal to size -1. So if you see what is the size of this circular queue, we can count the size, like 1 is this position, 1, 2, 3, 4, 5, 6, 7, 8. So it says that there we can insert 8 elements into this queue. So what is the size of this queue? The size of this queue is 8, and 8 minus 1 is 7. So we can say that if the front is pointing to 0 and the rear is pointing to size, which is 8 minus 1, which in this case it will become 7, in this case my queue is full. What is the other condition? We can say that the queue is full. Now suppose I inserted some value here like 30, 32, 37, 25, and after that I deleted 1 or 2 value. So from where the deletion will happen? The deletion will happen from the front index. So my front will move from, if I am deleting 2 values like 30 and 32, my front will move to this particular 37. Now if my front is pointing to 37, and if I am saying that my queue is full, where my rear will point? My rear will point to this index 1. Now in this case, this front is pointing to index 2 and the rear is pointing to index 1. So how we can convert this particular scenario in a form of logic? So if I am saying this front whose value is 2 and the rear whose value is basically 1, plus 1 will give the 2, right? So if I will say my front is equal to rear plus 1, it means my queue is full. Else in all other conditions there must be some place where we can insert some element into this queue. So these are the two methods which is very useful while writing the other operations of the circular queue. One is the queue is empty or not, and the other is the queue is full or not. So after completing these two methods, just like in linear queue, we have the methods to insert one element into the queue, which is in queue. In circular queue also, we have one method which says in queue. Now again, before inserting any element into this circular queue, we have to check that the queue is full or not. So we are checking that the queue is full or not. So is full is the method which we have just explained here. And if this particular method returns true, it means that the queue is full and we cannot insert any element into this queue. Else, if my front is pointing to -1, now suppose there is no element have been inserted into this queue. So in this case, this front is pointing to the -1 and the rear will also point to the -1 because we have initialized these two values with -1. Now, if my front is equal to -1, it says that there is no element have been inserted into this circular queue. So we will make this front equal to 0. And also, we have to move this rear to the 0th position. So what we can do? We can say that rear is equal to rear plus 1 modulus size. So in this case, if I say the rear is what? The rear is nothing but the -1 plus 1. So this value will become 0 and 0 modulus size will give you the 0. So in this case, this rear will also point to the 0. Now, if rear is pointing to the 0 and if I am doing items rear is equal to element, which is this is the element which I have to insert into this array at the rearth position. So rearth position is what? Its position is 0. So with this line, we are going to insert the element at the 0th position. So after inserting an element at the first thing, my front and my rear will point to the 0th index, just like I'm showing it here. Now again, suppose you want to insert one more element into this queue. So in this time, this queue is again not full. This front is equal to -1 condition will also not satisfy, because at the last time we move this front to 0, right? So now the front is pointing to 0, and now again the rear, which was also pointing to 0, now 0 plus 1 will become 1 and modulus of size. So size value here is 8. So 1 modulus 8 is, it will return 1. So rear is equal to 1, and in this way we are again pointing this element to the index 1, and now my rear will be pointing here and the value will get inserted here. So now the front is pointing to here and rear is pointing to here. Same way, the moment we are going to insert the elements into this circular queue, our rear will be keep on moving in this fashion. Now suppose if you want to delete one element from the queue, so to delete the element from the queue, we always go and delete it from the front, right? Rear is used to insert the element and the front is used to delete the element. Now suppose if I want to delete, before deleting any element from the circular queue, we have to see that is there actual any element present in the queue or not. If it is not, we will say that the queue is empty. We have already shown how we are going to use this isEmpty method. Now if this isEmpty method returning me as like true, it will come out of this method. Now if this queue is not empty and we can actually delete any element from the queue, we have to take that element from that index array. So it is saying items front is equal to, so it is saying element is equal to items front. So with this line, we are going to take the value of this index into this element, and once we have this, then we have to see two different conditions. Now suppose there is only one element present into the queue. How we can know that if there is only one element present in the queue? So to know this, if my front and my rear is pointing to the same value, it means that there is only one value present into the queue. So if this is the condition and if I'm going to delete that particular one element only, it means that I have to reset my front and the rear value. So if there is only one element into the queue, I'm going to reset my front and the rear value with -1. It will be same as suppose if there is only one element into the queue and you deleted that element too. In this case, this circular array will be in this initialized condition, right, where we are initializing the construction value. Now this front and rear will be set to -1. So this condition will get executed only when there is only one element into the queue. Else what we have to do, now suppose there is 5 elements into this queue. So if you're deleting this element which is present at the index 0, what will happen? This front will move to 1, right? So how we can move this front from 0 to index 1? So to do that, we have to use this particular modulus operator in this line. So here you can see the front is equal to front plus 1. Now 0 plus 1 is returning what? It will return 1, right? Now 1 modulus size, which is 8, will return you 1. So in this case, the front will get again moved to 1 index. So front will move here. So this is the way we are going to delete any element from the queue. We will see all these methods in detail in Eclipse, and we'll run the program into the debug mode also to know what is going inside the queue and coming out of the queue in slow manner. A part of this enqueue and dequeue method, we have one display method also. This method will be used to display all the elements of the queue. So again, to display any element, we have to check that actually the queue is empty or not. So isEmpty is the method which we are going to use to display to find out that the queue is empty or not. Once we get to know that the queue is not empty, we can use a for loop to iterate from front to rear. Now in this also we have to again use this modulus operator. So if you're not so much familiar with this modulus operator, I will suggest you to go and do some exercise on this modulus operator to get familiar with this. Now to iterate from front to rear, we are going to start from I is equal to front and I is not equal to rear. So I will start from the front. The I is the iterator which will start from the front and it will go all the way from front to rear. Now in this case, this increment will not happen as like I plus plus. We have to increment in this manner only, like I plus 1 modulus size. Now suppose I'm at position 3 and my rear is pointing to position 2. So if we do I plus plus, these things will not work. So I'll suggest you to go through this particular operator and see how this operator getting used. So this for loop will be used to display the elements of that particular circular queue. So now let's go into the Eclipse and see how these things are getting executed one by one. So let's move into the Eclipse. So for the sake of the time, I have already written these codes which I explained on the PowerPoint in Eclipse. So as I showed you that we have a constructor which will take the size of the circular queue and initialize the front and the rear value with the -1. Also, it will initialize the size with the size which we have just passed into this constructor, and it will initialize the array. Once this is done, we have two methods which will say that the queue is full or the queue is empty. So to check this full, we are going to take two conditions. One is like if my front is equal to 0 and the rear is equal to size -1, it will say that the queue is full. Else, if my front is equal to rear plus 1, again it will going to say that the queue is full. Else, in all other condition, my queue is not full. Similarly, if I have to check that my queue is empty or not, I will just go and check my front index value is equal to -1 or not. If the front index value is equal to -1, it will return true, else it will return false. Now suppose I want to insert one element into the queue, I'm going to use this enqueue method. So before inserting any element into the queue, I'm going to use this isFull method to know that the queue is full or not. If the queue is not full and we are going to insert the first element into the queue, which will happen only when my front is pointing to the -1, we will move the front to the position 0, and again we have to move this rear position from -1 to the index 0. So to move this rear index from -1 to 0, we are going to use this particular modulus operator with the rear plus 1 modulus size. I have already explained how this code is working. Anyway, I will run the program in the debug mode also and will try to show it. Similarly, we have a dequeue method where we are going to remove one element from that circular queue. And before removing any element, we are going to check that the queue is empty or not. And if the queue is not empty and we are removing only one element which is present in the queue, we have to reset the value of this front and the rear index value to -1, because in the constructor also you have seen that the front and the rear index value is set to -1. Only one element in the queue, we have to reset this front and the rear index value with the -1. Else, we have to move the front value after deleting that element from the queue. So this is the dequeue operation. Now, after that, we had a display operation where we used to display all the elements from the queue. Now, let me run this program and show how these things are working. So, let me run it as a Java application. So see, I have run this Java application. Now, let me explain how these things are getting executed. Now, you see, I have just initialized that queue with the size 8. Now once I initialize that queue with the size 8, if I'm going to call this dequeue operation, which is basically going to delete one element from the queue, but have you seen that I have not inserted any element into this queue? So if I have not inserted any element into this queue, how can I delete any element? So this will say that the queue is empty. So you are seeing this output, right? Queue is empty is coming from the queue.dequeue operation. Now after that, I'm going to insert 8 elements into this queue. So what is the size of this queue? The size of this circular queue is 8. So all this operation got successful. So I was able to insert 8 elements into the circular queue. Now the moment I'm trying to insert my 9th element into the circular queue, it is saying that the queue is full, because we are checking that condition right before inserting any element into the queue. We are checking that the queue is full or not. Now we are going to display all the elements into the queue. So this is the display method. Once we are calling this display, it is displaying all the elements which we have inserted into this queue. We have inserted 1, 2, 3, 4, 5, 6, 7, 8. So it is displaying all those elements. Now suppose I want to delete one element, or I want to call the dequeue operation. Once I call the dequeue operation, it will delete the element which is getting pointed by the front. So front is always pointing to this element, and the rear is pointing to the 8th element. So if I'm calling delete element, so which element will get deleted? The first element will get deleted, right? So this is the first element which is getting deleted from this circular queue. Now once this item got deleted, there will be one extra element again we can insert, right? Because we have deleted one element, and the size of this circular queue is 8. So here you can see there is only 7 element. So if I'm trying to insert element 10, I can easily insert it. So here again I have inserted the 10th element. So you can see this is the 10th element I inserted, and it got inserted successfully too. So these all these operations you can see it here. I inserted 8 element, then I was trying to insert one more element 9. For this I got this queue is full print, and after that I'm going to display that full circular queue. I was able to display it is saying from 1 to 8. And now if I'm doing this dequeue operation, this dequeue operation is giving me this first element which is getting pointed by the front. Now once I have this element, there will be one empty space left into this queue. So after that, if I am doing this in queue operation 10, this will get inserted successfully. And after that, again, if I'm displaying, it is displaying me the element which I have inserted. Now, after display, if I'm trying to again in queue, you remember the size of this queue is only 8, right? And at this point of time, we have already 8 elements into the queue. So it will say that the queue is full or not. So it will say that the queue is full. So this is all the operations we can perform on a circular queue. So now let me run this program into the debug mode and show you how these things are getting executed in a slow manner. So we mostly see these 3 operations, which is like in queue, dequeue, and display. In queue, dequeue, and display method. So let me set that pointer. Okay, I have set in queue, I set in dequeue, and one I set in display. Okay, so let's run this code into the debug mode. So if I'm running the code into the debug mode, you see it initialized all that thing here. It initialized the value with the 8. So let me debug mode. Here I can show you all the variables. Just let me print. Yes, so now this is good. So once I initialize this circular queue, you can see that the front is initialized to -1, the rear is also initialized to -1, and the size of the array is also initialized to 8. Now if I'm trying to dequeue without inserting any element into the circular queue, it will go and check that the queue is empty or not. So once it is checking that the queue is empty or not, I can press F6 and it is going inside this method saying that the queue is empty. If the queue is empty, it will return here, right? Now if I'm going to insert one element into the queue, it is going and checking that the queue is full or not. At this point of time, you can see my front is pointing to -1 and rear is pointing to 1. So in this case, this queue is not full, right? If this queue is not full, it will go into this else condition. And actually, this is the first element which we are going to insert into this queue. So this is the first. So if this is the first element, where my front will point? My front will always point to -1 if we are going to insert a first element into the circular queue. So if this is the case, my front will move to the 0. Now in this case, my rear also has to move to 0, right? So how we can do that? So rear minus 1 plus 1 is 0, and 0 modular size will return you rear value as a 0 only. So see, here the rear is also set to 0. Now item rear element, what it will do? At this point you can see all these elements are set to 0, right? Now the moment I execute it, we are inserting first element into the queue, and the first element got inserted here. Now again in the second case, as I was saying, right, this front is now not pointing to -1, it is pointing to 0. So that will not get executed, and now my rear will get executed. So rear value is here 0, right? Now 0 plus 1 modular size will return you 1. Now see, this rear is getting moved, right? And now this item is also getting inserted. So in this case, if you see, in this item 1 and 2 got inserted. Now we are inserting the third element. So rear move to 2. So 0, 1, 2 means third index. So like this it is getting inserted. So let me insert all this thing, whatever I wanted to insert, like 8 elements we have to insert, right? Now see, all 8 elements got inserted. Now the moment I'm trying to insert this 9th element, it will go and see that the queue is full or not. Now at this point my queue is full. So it will say that the queue is full. Now again it will go and display the method. So for display, I was saying, right, it is going and checking that the queue is empty or not. Because the queue is not empty, we have already inserted 8 elements into the queue. All these things can be, you can see it is, as the queue is not empty, we can go and print the queue. So for this, we are going to again start from I equal to front, which is at this point of time it's 0. So for this it is very easy. It is starting from 0 and going to the rear index. So this is nothing much here. So I'm just going, and you can see here it's all thing is getting printed here. Now once it's got printed, if I'm trying to dequeue an element, for dequeue it will do what? It will go and check that the queue is empty or not. At this point of time, how many elements are there in the queue? There are 8 elements, right? And the front is pointing to this element. So it will go and take this first element. So what is this element it is taking? It is taking the -1. Now once -1 it took, this front is equal to rear, which is not correct. So it will come here and it will move the front from 0 to 1. So see, now this front moved from 0 to 1, and it will return that element which it took from the 0th index. So it moved here, and you see this element value is 1. Now this one, it is saying that the deleted element 1. Now again, if you want to start this display, right, from where you can display. So again, front this time pointing to 1 and rear is pointing to 7. So it will go from front to rear and display all the elements into the queue. And similarly, see, everything is getting displayed. And yeah, pretty much done. Right now this in queue is again full because the queue is already full. Yes, this is all about your circular queue data structure in Java. Hope you like this video. If you have any comments, please write in comment box. I will try to answer it. If you like this video, please subscribe to my channel. Till then, have a great day and goodbye.